My name is Stella, and my topic today is talk on natural gas. And the presenter on the webinar, the name got cut off, but it's probably Sam Thomas, Chairman and CEO of Chart Industry. And basically, natural gas has a very broad topic, but he just go on randomly saying what he feels like and provide evidence on most of the graph charts and stuff. And the main topic he said was, what are we going to do with all this natural gas? And I think the webinar was done on March 14, 2011 for the ChE spring meeting. He started with saying U.S. shale gas production has increased 14-fold over the last decade. And what shale gas means is it's a natural gas form being trapped within shale formation. On the graph it shows Barla increases the most over 2010, and blue stands for Haynesville, Fayetteville for green, and Marcellus for blue, orange for Woodford, and Lease would be Eagle Ford. That's for the annual production by major shale gas field from 2000 to 2010. This is a source and use for the United States Energy on 2009, which is a total of 94.6 quadrillion BTU of energy use from that year. 37% of total use goes to petroleum, and second would be natural gas, 25%, 21% goes to coal, and 8% for renewable, and 9% for nuclear. And this is for the energy demand, and 29% of the energy is used for transportation, 20% goes for industrial, for non-electric, and 10% goes to electricity for industrial. And this is electricity for commercial for 15%, electricity for residential for 15%. On this one, residential and commercial for non-electric is 11%. On the pie chart, it summarizes that 30% of energy goes to industrial and 42% goes to residential and commercial, which is almost 50% off the energy demand comes from residential and commercial, which is equals to electricity or power people use at home, stuff for TV, stuff like that. This is another chart. There's a lot of lines on it. It shows every category of petroleum, natural gas, coal, renewable, and nuclear, which part of those supply sources is used on the demand sectors. Petroleum is used in transportation, industrial, residential, and commercial, and for electric power. If you go look on the lines, it shows numbers on there. It's fairly hard to look at, but the number is like 72% petroleum over the 37 is used in transportation. It's kind of hard to rationalize it, but they all should add up to 100%. That means how they're divided in each category they're used on. And on his presentation, he also showed where will we use all this natural gas. For natural gas, only 30% is utilized or reused in transportation. Most of them are used for industrial purposes. The second would be we use natural gas for central electric power, and 21% for residential, and only 14% for commercial. This is his prediction, or he found it for a picture for projection from 1990 to 2035. He also mentioned that 30% of domestic gas production growth outpaces 16% consumption growth, leading to declining imports. He provided this graph that showed over from 1990 to 2009, he predicted there would be 11% of net imports, but as it goes to 2035, it will decrease to 1%, as some of the shale gas increases from 14 to 45%. This is a world liquid natural gas trade routes that he provided to, that he mentioned in there. Says global trade in liquefied natural gas moves us toward global market pricing. Most of the trade routes goes to Southeast Asia right here, and then shows the future route that could probably emerge in the future. He also mentioned something really interesting in there is showing natural gas vehicle growth. The NGV stands for natural gas vehicle. The average growth for total numbers since 2000 is 20.8% per annum. And the red bars shows the projected growth from 2006. So we're already on 2012. This is the past presentation. So we have on 2009, it shows we have 12 million, almost 12 million of natural gas vehicles. It's been going up. Shows a pretty steady growth of the natural gas vehicle. This is the amount of natural gas vehicle by countries. The United States has the lowest amount of natural gas vehicles of 2008. The worldwide total of 9.6 million. And Pakistan has the highest amount of natural gas vehicles that have 2 million of them. And this is the amount of natural gas filling stations available at different countries too. What's interesting is the United States has the lowest amount of filling natural gas cars, but it actually has the highest amount of filling stations per 1,000 vehicles. Just right, the yellow one. The graph is quite blurred since I pulled it out from his presentation. The main reason he mentioned in there to use natural gas instead of oil is because we need to reduce dependence on oil. This graph shows the economic cost of the United States oil dependence. It shows we use a lot of money to spend, like for the country to use on the oil. So if we actually go to natural gas, we'll actually save a lot of money too. The next reason to use natural gas is to reduce greenhouse emission. This column right here shows the annual carbon dioxide emissions at different countries, and this is the percentage of the global total, with 100% for the world, and then 22.3% of the carbon dioxide emissions come from China, and the United States goes to the second, has like 19.91% of carbon dioxide emission yearly. And Iran actually has the least amount of carbon dioxide emission. The next slide says why natural gas is such an opportunity. It's because we have a lot of places that available domestically has shale gas or natural gas that possibly could be found and used. Like these places right here, kind of blurry to tell, but we have a lot of places in America that's not being found as a source of natural gas. And besides that, we have natural gas is clean. It makes less hydrocarbon stuff, produce less heat too. And this is a quote he used in a presentation by President Obama in November 2010. Power generation wise, why do we need to use natural gas? Is because he predicted in the future that it will cost more if we release carbon dioxide. It has a lower operating cost if we reduce